Okay, hello everyone, welcome. Can you hear me? Okay, thank you. Okay, just be waiting 1 minute, then we'll start. Okay, so we will start. So basically, today is our 6 number days, and basically today's session I try to discuss about that machine learning. Okay, so how we can easily apply the different types of machine learning and work for the classification. So different types of land use land cover classification using the different types of algorithm. So I will try to explain all of things from beginners to advanced level. Then I hope you can easily create any kinds of land use land cover classification using the different types of algorithm. Okay, so let me share my screen. Okay, can you see my screen? Is it visible? Okay, thank you. So basically today's session is about that introduction to machine learning in Google Earth Engine. So how we can easily use the machine learning in Google Earth Engine. We'll also discuss about that. Then how to make land use land cover mapping using machine learning, basically supervised and unsupervised. Okay, both of algorithm I will try to explain and also show you the practical example. Mainly supervised learning, we talk about that random forest, then cart, mainly classification and regression trees, support vector machine, minimum distance, and others classifier, how we can easily use using Google Earth Engine, and further how we can easily make the land use land cover classification map. And after creating the map, we also need to check the accuracy. So further we also discuss about that how to check the different types of accuracy: overall accuracy, kappa accuracy, producer accuracy, or consumer accuracy. So this type of things we also try to explain, and calculate the land use, land cover, classes, area. Okay, how we can easily check the area. We also discuss about that, and how to add the legend, and finally how to export this land use, land cover mapping. We also discuss about that. So let's go start. Let me open my slide. So basically, in this case, we discuss about that machine learning. So basically, machine learning is one kind of artificial intelligence branch, and this artificial intelligence that enable compute to learn pattern from data and make decision or prediction without being explicitly programmed. Okay, so for the machine learning, we find out the different types of machine learning, such as supervised, unsupervised. Okay, so in this case, we try to compute and learn the pattern of our data. Suppose I have a data. In this case, mainly we talk about the satellite data. Okay, or satellite imagery. So this type of satellite data or imagery, just I compute to learn pattern from the data, and further it automatically make the decision or prediction. Suppose I take some data, it's a water body, it's a build up, it's a vegetation, it's a cropland. So then it automatically learn from this type of data, and further it easily make the decision or make the prediction for it's a water body, it's a forest or build up or barren land. So this type of thing is automatically done using the machine learning. So we find out the two types of machine learning, mainly supervised, unsupervised, as well as semi-supervised. Sometimes we also use, and also reinforcement learning is also available for the others. But in Google Earth Engine platform, basically we use at these two type. One is the supervised and unsupervised. But as well as if you want, you can also apply for others platform. We also talk about the semi-supervised, as well as we also find out the reinforcement learning. Okay, so this is the another types of algorithm for the semi-supervised and reinforcement learning we need to use. But in Google Earth Engine, we can easily perform the supervised classification as well as also unsupervised classification we can easily do using this. So now we talk about the what is the supervised, what is the unsupervised. So basically the model is trained on level data. In the supervised classification, this model is trained on a level data, mainly input output. We need to add the level data. But unsupervised classification, when you do, then you don't need to take any kinds of level data. Okay, suppose if I just use here the supervised classification algorithm, first of all I need to create the label data. And what is the label data? Label data mainly it stored the information for specific classes. Suppose I create the label data for water, I create the label data for build up, I create the label data for forest, I create the label data for water body. So this type of label data I need to create when I apply the supervised classification. But when you apply the unsupervised classification, you don't need any kinds of label data. We don't need any kinds of label data. We don't need any kinds of pre-categorized data. So this type of data we don't need. So this is another algorithm for unsupervised classification. And supervised classification, when you apply, you must need the label data. Label data is also called the pre-categorized data. Pre-categorized data we need, but when you apply the unsupervised learning, we don't need any kinds of label data, or pre-categorized data we don't need. So basically supervised classification, we can apply different types of algorithm such as random forest, support vector machine, then decision tree, then cart. And for unsupervised learning, we are using the clustering. K means clustering. So further we'll also discuss about this type of algorithm, how we can easily use. So now we talk about the what is the classifier. Okay, so in Google Earth Engine platform, we have lot of algorithm for our classification. Okay, so this type of algorithm called as a classifier. Suppose the algorithm which element the classification on a dataset is known as a classifier. Suppose the which algorithm I apply in my dataset for the classification, and this algorithm called as a classifier. Suppose random forest is one kind of classifier. A decision tree, it's one kind of classifier. Support vector machine, it's one kind of classifier. Okay. Mainly we find out the two types of classification. Any kinds of machine learning, we find out the two types of classification. One type is called the binary classifier. Binary classifier mainly the possible outcome only two. Okay, suppose yes or no, male or female, cat or dog, forest or deforestation. Okay, this type of only for the two outcome or two classes, it's called the binary classifier. And when you find out that more than two outcome, it's called the multi-class classifier. Okay, so multi-class classifier, we can say that crop types classification. Suppose types of music, land use, land cover classification, more than two classes. So this type of classification called as a multi-class classifier. Okay, but when you apply only for the possible outcome, only for the two, suppose cat or dog, spam or not spam, male or female, yes or no, forest or deforestation. Okay, so only for the possible outcome two, then we need to use here the binary classifier. And multi-class classifier, basically when possible outcome more than two, then it's called the multi-class classifier. So now what is the process to make the land use land cover classification in Google Earth Engine using supervised? Okay, first of all I discuss about the supervised, then we talk about the unsupervised. So supervised learning, we already know when you apply the supervised learning, you must need the label data, or also called the pre-categorized data. Okay, suppose label data, suppose you want to classify total 4 class: water body, build up, vegetation, and barren land. So then these 4 classes you need the label data. Okay, so we can easily create that this type of label data or pre-categorized data we can create easily. Further we simply apply the model and then make the classification. So first of all, what is the process? First process is that selecting your study area. Basically which area you want to make the land use land cover classification, then simply use it. After that, choose and filtering the image collection. So in this case, if you want, you can use at the Lancet, or if you want, you can also use at the Sentinel. Okay, any image collection we can simply use. Then filter your image collection. Okay, this is second step. We already know that the lot of way to filtering the image collection. So in this case, you can simply choose in the second step, choose your image collection. If you want, you can also use the Lancet or Sentinel. So basically when you apply the Lancet, we find out the 30-meter resolution. When you apply the Sentinel, we find out the 10-meter or 12-meter resolution of our satellite, of our land use land cover classification map, because Sentinel is high resolution than Lancet. Okay, but Lancet is available from very past time. We can find out the satellite image from year of 1973. Okay, 1973 we find out this satellite image, mainly Lancet. But for the Sentinel we find out from 2015 or 17 it's available. So when you work with historical data analysis, suppose historical land use land cover changes you want to monitor, then you try to use here the Lancet. But when you for that, suppose for present time, then you can easily apply the Sentinel, because Sentinel is high resolution than Lancet. When you apply the sentinel, then we find out that more better map, more better land use land cover classification map we can easily find out. Okay, after that, third step, it's a supervised learning. So that's why we need to collect the training point. We need to collect the training point. Suppose I want to classify total 4 class: water body, build up, vegetation, barren land. So these 4 classes training point I need to collect. So how I can collect the training point? There are a lot of things I also explain when I talk about the practical. So then we are just collecting the training point from our satellite imagery. If you want, you can also use the ground truth data. Simply visit your study area and take the GPS location for a specific feature. Suppose latitude, longitude, these type of things you can easily apply, and you can easily collect the training point. Okay. After that, just merge all of training point together. Okay. Suppose all of training point, simply merge together and make a one feature collection. Then we simply select the bands. So basically in this case we are just make the extract the pixel value. Suppose this type of training point, extract the pixel value. Suppose water training sample, extract the water pixel value. Suppose vegetation pixel training point, extract the vegetation pixel value. Okay, pixel value mainly band's spectral signature value. It also called the spectrum value. So we simply select the band. So it also different types of land use land cover classification. We need to select the different types of band, as well as we need to also input some external band to get the high accuracy of land use land cover classification. Then we can simply extract the pixel value. Okay, so this type of pixel value or spectral signature value, it's just we create using the sample regions function we need to apply. We just make a data set. So basically it's called the data set. Which pixel value I find out for each classes, it's just called the data set. So further this data we simply spilled. Suppose in the machine learning we are just use some data for training and also use some data for testing. Okay, suppose just simply spill the data set into training and testing. Suppose 80% data for training and 20% data for testing, just simply spilled. Or 70% data for training and 30% data for testing. Thus spill the data and then create the classifier. Simply create the classifier. So in this case you can apply different types of algorithm. Suppose random forest or cart or also support vector machine. Okay, and train the model using training data. Suppose I just simply spill 80% data. So it is 80% data I use in my model and train my model. After that, simply model connecting with our satellite imagery. So when this model I simply connect with my satellite imagery, it automatically create the classified image. So then we can easily find out the land use land cover result. We can easily find out from here. And finally we just check the accuracy. So for that we can easily create the confusion matrix table and check the accuracy. Suppose overall accuracy, kappa accuracy, producer accuracy, these type of things. And finally calculate the land use land cover classes area. So let's go. We try to show you that all of those step by step practically. Then you can get the more clear idea how we can easily apply the Google Earth Engine to make the land use land cover classification using supervised machine learning. So let me open my code editor. Okay. So first step, you need to import your study area. Which area you want to make the land use land cover classification. Okay, so let's go try to import our study area. Suppose I want to work for this study area, just import Dhaka city boundary, and I put the variable name as a ROI. Take a variable, just ROI variable, and I want to display it as a layer, map.add layer, and call the ROI, and then just center object of given study area, zoom level suppose 10. Now run the code. So now first step is done. Okay, so simply import your study area and display. Okay, so now second step. So in this second step we need to filter, choose and filter. So in this case if you want you can use here the Lancet, or if you want, you can also use a Sentinel. So basically, Lancet and Sentinel, it depends on your research work. When you work with historical data analysis, suppose from 1990, then 2000, 2010, 2020, okay, then you must use here the Lancet, okay, because Sentinel-2 satellite imagery is available from 2017 or 2015. We find out this satellite imagery. So when you it's also different, but process is the same. When you apply the land use land cover for image classification, this process is the same. Any satellite imagery, we are just applying the same process. So in this case, I will show you for that Lancet. Further, you also try to apply the same model using Sentinel. Just difference only for the resolution. Okay, Lancet 30 meter, Sentinel 10 or 12 meter. We find out this pixel size. So Sentinel satellite imagery is more better resolution than Lancet. But Lancet is available for the 1973 and Sentinel is available from 2015 or 17. Okay, so let's go try to use the Lancet. And if you check, we find out different types of satellite version, Lancet 9, 8. So which time period you have. So suppose you make the lens image from the present time, or you can see the very past time. So which year you need, simply choose the image collection, Lancet 9, 7, 5, or 1 to 5, or 4, or Lancet 9. I choose the Lancet 8. And basically for the surface reflectance, it also useful for making the land use land cover classification. So you can see it's available from 2013 to 2025, 29 January. So this image collection I want to use. So let's go try to just copy this snippet ID and take a variable. Suppose I put the variable name is image and then paste. So now it imported and I put the variable name is the image. You can put any name as a variable. So it default just put here the image. So now this image collection I choose Lancet surface reflectance satellite imagery. So now it just filter. Okay, so I already discussed lot of method for filtering. So different types of method we can use for filtering. Suppose median composite, mosaic composite, as well as also single date imagery. So a lot of things we already discussed for the previous classes. Just you simply filter your image collection. Okay, so in this case, suppose first of all we need to filter using filter bounce function. Basically where you need this image, I need the image from a study area ROI. Further just filter, suppose filter metadata, and if you check, I want to need the image cloud cover less than suppose 1. Okay, I just consider only less than 1. And further, when you need the image for a specific time period, okay, when you make the land use land cover map, what is your time period? I put the time period, suppose filter date function, and apply the specific time period. Suppose year of 2025, 0101 from year of 2025, suppose 0129. So present time, I want to make this land use land cover classification using Lancet. Okay, so now after creating this type of things, we need to check how much images are available. After filtering, how much images are available, you must check. So for that, just use the print function and call the image and use the size function. So now it's computing how much images are available between this time period. You can see there is no image, it shows the 0. So that's why in this time we don't find out any image between this time period. Less than 1% cloud cover image is not available. So now what can I do? For that, if you want, suppose you must need the image, so then you try to increase the cloud cover. Suppose I put here the 10. So now let's check, one image is available. You can see when I increase this, we find out the one image is available for this study area. So this one image, okay, let me just show you this one image information. So print, I just put here the image and just run it. So now we find out all of information. So you can see only for the one element, mainly one image we find out. And you can check all of in feature. This one image, basically if you check this, you can see we find out 8.68 cloud cover. We find out this cloud cover. And if you check what is the acquisition time, if you check, we find out, you can see the 7th January. Okay, for this acquisition time you find out. So if you want, you can also use this imagery. Okay, suppose just I take a variable, I put the variable name, suppose image again, and put here ee dot image, and then call this image id. So if you check, this is the image id. Just copy this image id. This is the id. Just copy and paste. Okay, and further simply display this imagery. So further just add a layer, map.add layer, and put here the image. Okay, and then add. So now these tiles or scene will be added in our map. We find out this type of scene. Okay, so you can see we find out this type of imagery, but it show the whole tiles, but I don't need for the whole tiles, I need only for the specific study area. So for that, just use here the clip with your boundary, just ry, and run it. So we find out only for this study area, we find out the image. So in this case, I just take only for the single date image, but it's not necessary all time you just take the single date imagery. If you want, you can also just create the median composite or mosaic composite, and when you work with for big study area, then one tiles is not fully fill up your boundary, then you must use here the median or mosaic composite, then it will be fully fill up and you can easily work with that. In this case, we find out the Dhaka city boundary, it's a small study area, and this tiles basically whose acquisition time is that 7th January for very recent imagery, 7th January. So these tiles basically we can easily find out. Okay, and this tiles is also fully overlay with my study area, so that's why I can easily use it for the single date imagery. If you want, you can also create the median composite or mosaic composite. Okay, and can also work with that same process. So let's add the different types of band combination we try to add. Suppose I put here red, then green, and blue, stressing suppose 98%, and apply. So you find out this type of imagery, and if you check, it show very high value, you can see 8963 point something. So this type of bands pixel value we also need to reproject it, scale value we need to reproject it. So how I can reproject it? For that, they already give some value, you can see they already provide that scale value and offset value. Okay, so you can see all of bands are the same scale value and offset value. So we try to use this type of scale value and offset value, and then just reprojected the pixel value to get the proper wavelength. So just simply copy the scale value, just copy this scale value, simply it says image. Okay, so this type of image we can easily connect, but when you connect the image collection, suppose I have a 10 image, so this 10 image I want to multiply with this value, so then we need to create the function. But when you multiply with the image, then don't need to create the image, don't need to create the function. Suppose in this case I just find out total 10 images. Okay, suppose I find out the 10 images, so this 10 images I want to multiply this value, scale value I want to multiply, then you need to create a function, and this function you need to connect with the image collection, maybe 10 image collection you need to connect. But in this case I just work as a single image. Okay, it's not the image collection, so that's why I can easily apply the multiply without creating the function. Okay, so let's go simply write here the multiply, just write here multiply, and then paste this value, and also add the offset value. So this is the offset value, just copy and paste. So further just run the code. So now we find out the proper pixel or wavelength value. Okay, but when you multiply this type of value in an image collection, then you must need to create the function. Okay, you must need to create the function, but in this case this type of value I simply calculate using an image, using a single date image. So that's why don't need to create the function. But when you apply it for the image collection, must you need to create the function, and further you can just use it. Okay, so let's go. We try to add the band combination and add the, so just click on here, and we can easily find out, suppose put at that red, then green and blue, stressing suppose 98%, and for that apply. So now we find out this type of natural color band combination look like that. Just import and just copy and I paste here, and I put, say it's a imagery, and run it. So now you find out this type of natural color imagery. Okay, so now how I can, so our second step is done. Okay, mainly we are just choose and filtering the image collection. Okay, this two step is done. So now we talk about the third step, how we can easily collecting the training point. So there's a lot of way for collecting the training point. If you want, you can simply visit your study area and you can take some GPS location for specific classes. Suppose I simply visit this study area, I take the class, suppose water body build up, mainly I take the GPS location. Okay, suppose previous class I already discussed about that how we can easily uh, add the CSV file. Okay, suppose you can see this type of CSV file, I simply store it latitude, longitude, and also some suppose class. Suppose this latitude, longitude, water body, then suppose vegetation. So this type of latitude, longitude value, we are just collect from our study area for specific classes. Further, we are just simply just import in Google Earth Engine. I hope you already know about that how we can easily import this type of chart in Google Earth Engine. Then we simply just extract the pixel value and also work with that. So in this case, if you have this type of ground truth data, you can easily import in Google Earth Engine, and further you can also use this type of things as a ground extract the pixel value or training sample. Okay, so in this case, suppose I don't have the ground truth data, so just I take the training sample from this satellite imagery. Okay, so how I can choose the different types of feature from satellite imagery. So basically in this case, we are just use here different types of band combination. It's very helpful. Different types of band combination we need to apply and choose and select a specific feature. So in this case, this is the one kind of band combination we already know. It's called the natural color. Natural color mainly what human eye can see naturally. So we can easily find out, you can see this type of green pixel indicating about the vegetation, or it's indicating about the water body, this type of lake. Naturally what human can I see, it's the natural color. But when I apply suppose another band combination, suppose I apply here near infrared, then red and blue, custom statistics for 98%, and apply. So now it display the another color. You can see now all of water body show as a black color. You can see this type of black color is a water body, this type of black color water body, and vegetation show as a red color. So this type of red color indicating about the vegetation. You can see it's a vegetation, and this type of color indicating about that barren land. Okay, and water body show as a black color or dark color all time for any study area. When you apply the band combination, then we can easily find out the water body as a black color or dark color, vegetation show as a this type of red color. Okay, and we find out this type of color as a barren land. As well as if you want, you can also apply suppose short wave infrared 1, 98% I keep, and then apply. So now we can find out the another band combination. Okay, it's adding. So now we can see we find out this type of imagery. So from here you can easily find out that this type of barren land show as this type of gray color, vegetation show as this type of green color, water body show as this type of black color, dark color. So we can easily identify. So this type of vegetation we can easily identify from here. Okay. So now we are just using different types of band combination, and further we simply choose a specific feature from our ground. So let's go take the training sample from here. So to getting the training sample, just click on the marker. In this case, I just click on the marker. Again, see it show as a geometry. Okay, just click on the geometry. Suppose I take the training sample for water body. Just click here, what does start here water. Then put the feature collection. Then property, set the property, suppose class, and assign the value 0. Okay, so in this case if you want assign the value 1 2, it's not a depend, but it will be start from the 0. 0 refers to the first item. Okay, so now this water I just
Excuse
set
me.
a, yes please.
There is a lot of interference. Can you please repeat what did you say just now? Because I didn't understand what we
Okay,
are
just
doing.
okay, just a minute, I think some network issue, just a minute. Okay, I again explain. Okay, so now we are just take the training sample for our is classes. Okay, let me just remove it again. Just remove. Okay, so now we are just taking the training sample. Suppose I just take the training sample for water body. Okay, so we already know about that it's a water. Okay, we already know about it's a water body. You can see this is the water body, and we can easily get the idea using the different types of band combination. Okay, so basically we are using here the band combination to identify different types of feature from the satellite imagery. Okay, so you also get the more details. Suppose I simply search here Landsat 8 band combination. So you can check, suppose from this link you can get the more better idea which band combination provide you which information we find out. Suppose if you check, um suppose you can see 432 mainly red, green and blue. Okay, when we apply the red, green and blue, then we find out this type of natural color. Okay, basically what our human eyes can see normally. Okay, healthy vegetation show as a green, unhealthy flora is a brown, urban feature appears as a white color. Okay, and water is a dark or blue, we find out. Also you can see this is the another color infrared. Basically this is the near infrared. Okay, red and green. When I apply this band combination on my satellite imagery, then I can easily find out this type of uh, visualization. Okay, so in this case vegetation show as a red color. Okay, water body show as a dark color, we can find out. Okay, also you can see this is another one, short wave infrared. So this is another band combination. So we are just use here the different types of band combination to identify different types of feature from our satellite imagery. Also you can see this is another one, 652 mainly short wave infrared one, near infrared and blue. When I apply, then we can easily identify the agricultural land. Okay, so basically you can see here agricultural land have a pattern. Okay, it's just a shape, suppose rectangle shape or square shape, this type of agricultural land. But vegetation or trees, this type of random shape. Okay, not any kinds of specific shape. So you can see we can easily it's a square shape, we find out green color. So we can consider it's a agricultural land or crop land. We can easily identify, and we can easily get it's a random distributed, there is not shape, so it just show as a vegetation. So it's a vegetation we find out in here. Okay, and also you can see this type of bare earth has a magenta hue, so this type of color we find out as a barren land, this type of color. And blue is the word. So when I apply this thing, we can easily find out this type of visualization. As well as when you identify any geological feature, so just apply it. So then we can identify the geological formation, lithology feature and fault, we can easily identify. Or bathymetric, you can see basically bathymetric, it useful in the coastal or bathymetric or aerosol studies because it reflects the blue and violets. So this combination is good for estimating the suspended sediment in the water. So we can also apply, then we can easily find out that this type of feature. So now we are just use the different types of band combination, and further we just choose for a specific feature from our satellite imagery. Okay, so now suppose I just use different types of, I can easily identify it's a water body, it's a vegetation, I already know. So now I want to take the training sample for each classes, which class I want to classify it. So let's go try to classify it. Just click on the marker. After that, just click, you can see that this is the layer properties, and put the name. You can put any name. Suppose in this case I take the training sample for water, I simply write here water, then import as feature collection. Okay, I make the point feature collection for water pixel. Okay, just put the feature collection. Property, so you can put any name as a property. So I put the property name, suppose class, and set the level, mainly value, I set the value 0. So all of 0, it's indicating the data for water. Okay, so I set the level, 0 level, this is the data for water. Okay, 0 level, this is the data for water I consider. So just I click on the OK. So now I can see it show the water. I just simply take the training point from this water body. Okay, just take the training point. Just take the training point from this water body. So now how much training sample I collect for each classes? So basically it's depend on your accuracy. Suppose after creating the land use land cover map, I find out very low accuracy, then we need to increasing or decreasing our training sample. But first time we try to take more than 30. Okay, 30 training sample for each classes. Okay, before first time. Okay, but after that if I face any problem, suppose I find out the very low accuracy, then we are just increasing our training sample or decreasing. Sometime you also need to decrease the training sample. Okay, but in this case suppose I just keep, this is my training sample of the water body. So now water body is done. Okay, so now I take the another training sample, suppose vegetation. Okay, so let's try to take the training sample of vegetation. Just click on the new layer and then click and put the name. Suppose I take the training sample for vegetation, just click on here vegetation, and same as import as feature collection. Property name is the same for all classes, property name is the same. Suppose I put the class. Okay, and set the value for 1. So now all of training sample for vegetation, I set the level as a 1. So 1 means vegetation. Okay, so just I click on the OK. So you can see now vegetation is select. Just select the vegetation and take the training sample from the vegetation. So basically this type of green pixel indicating the vegetation. So just I take from here.
Excuse me, quick question.
Please.
It's about the simple selection. It not it doesn't have something in relation with the band selection.
Okay, so first of
I
all,
mean, if I change the band selection or the combination, if
it's not effect in this case. You can see here basically this is our process. If you check our step, so we select the bands up before we, after taking this training sample, then we select the bands. So which band I want to use to extract the pixel value. Okay, so first time we are just use here the different types of band combination and get the idea. This is the water body, this is the vegetation, this is the barren land, or which class you want to classify it. Get the idea from the band combination. After taking the training sample, all of classes, we are just merge all of training sample together. Further, we are just selecting the bands. Suppose I just use all of band b1 to b7, all of band I simply select, and then all of bands I just extract the pixel value from all of training sample for different classes. Okay. Okay, so now this
yeah,
band
thank you.
combination is not any effect on our band's value. So basically this type of things we are just use to get the idea what, where is the water body, where is the barren land, where is the vegetation. This type of idea we can generate from this band combination. So let's go take the. Okay, let's do it. After that I take the training sample for Berlin. Just put here the Berlin, same as feature collection. Set the property name, suppose class, and set the value for 2. Okay, so all of training sample we are just set the level 2. Level 2 means for Berlin. Okay, then okay. So now you can easily identify, you can see this type of place is barren land. Just take the training sample from here, training point. Okay, finally we take this training sample, suppose for build up, and same as suppose a feature collection. Set the property name I keep same for all classes, for class, and set the value for 3. Okay, so you can see first one 0, then 1, then 2, then 3 we put in here for the build up. And you can also change the band combination. It's not effect on your work. Suppose I simply click on here. Suppose in this case I want to apply the another band combination. Suppose uh, red, then green and blue, and then apply. Okay, then we can easily take this type of place. We find out this build up. Okay, so just select the build up and this take this training sample. And when you take the training sample, you can also compare with the satellite imagery to get that more accurate result. When you work with suppose present time satellite analysis or image classification, then you can easily compare. You can see compare this type of things with your base map. Okay, you can easily compare. So basically this type of pixel indicating about that build up. Also you can see this white color pixel, it's indicating about the build up. Okay, so let's we take this type of training sample for build up. So you can see it also added this type of information: water, vegetation, barren land, and build up. Okay, so when you just suppose work with CSV file, so the same process. Suppose I have a CSV file for water body sample. Okay, so what can I do? So just click on here and go to the CSV file, then simply source your file. Suppose water body, mainly latitude, longitude, this type of water body, latitude, longitude have the water body class. So you can simply choose your file, and further you can see add property. It's very important, add property. Click on the add property and put the property. So in this case we are just keep property name as a class, and for the value set the value for water suppose 0, and further just apply, just upload. Okay, so these things easily upload in your asset file. Okay, so when you work with ground truth data, basically ground truth data is the combination of latitude longitude value. Suppose this type of latitude longitude value I have for water body, only water body in this case I suppose. So now this type of things I simply import. So just I simply import and set the class, add the property and set the value for 0. Okay, after that we also need to mention about that column name, latitude longitude column name. Just use the same name and then upload it. So now these things will be uploaded in our asset tab. So from this asset you can see, suppose this is CSV data, just simply click on here and then put the name. It says suppose water. Okay, water, and then you can also work with. Okay, so in this case we are not using the ground truth data, we are just take the training sample from satellite imagery. But sometime for the different types of classification, mainly for crop types classification, we also need the ground truth data, as well as also suppose a specific species classification or crop or tree types classification. So this type of things we also need the ground sample. Okay, so for that you can just create this type of CSV file which is including the latitude longitude and also including the class name. Suppose for one CSV file for one sample, suppose this CSV file just keep only for the water. So for the vegetation create the another CSV file, for the water body create the another one, for the forest create the another one sample, and further individually just upload. Click on here and then upload. Suppose I want to upload for water body, just click on the add property and add the property name, suppose class, and set the value for 0 and then upload. Okay, further just simply click on here and add your data. So in this case this type of data we generate from our CSV file. We are just simply call different types of band combination, and further we simply add the training sample. Okay, so now after taking this training point, we need to talk about that this step we need to merge all of training points together. Suppose in this case just need to merge all of training point, water, vegetation, barren, and build up, simply merge. So let's go, just merge. Just take a variable, I put the variable name suppose samples, you can put any name. So now just write the variable water, it merge with vegetation, then it's merge with barren land, then merge with for build up. Okay, simply merge. So now all of training samples stored in this variable. Okay, so let me just print it. So print this samples and run it. So now we find out the information, total sample number. You can see total 164. Okay, total sample for water, vegetation, barren land, and build up. We find out the total 164 samples. And you can see all of samples, we already make the pre-categorize. Suppose if I just click on here, if you check the properties, this is the one. Okay, this is the one. So one for vegetation. So this training sample I trained for vegetation. Okay, so I create the pre-categorize or label. I set the label one, this training sample. Suppose I check another one. Suppose just click on here. You can see this property is for class for 0. 0 mainly water. Okay, check the another one. So each classes, each training sample, we set the label. It's the label data. And label data must need when you apply the supervised learning or supervised classification method. But unsupervised classification method, you don't need to take this type of label data. Okay, so now move to the next step. In this case, just selecting the bands. We need to select the bands. So this type of bands were used to extract the pixel or spectral signature value. We just simply extract. So let's go just make a list. Just take a variable, suppose bands, and make a list all of bands which you want to work or which band you want to extract the information. So in this case, if you check, I want to use suppose B1 to B7, all of band I want to use, and further I want to extract the spectrum value. Okay, so let's go try to use. So simply write here SR B1, then suppose SR B2, then put here SR B3, SR B4, SR B5, SR B6, finally SR B7. So this is the band. This band is already available in my satellite imagery. Okay, but sometime for our for complex classification, to increasing the accuracy, we need to add some external band. Suppose I need to sometime need to add suppose NDVI band or NDWI band or SAVI band. For the different types of classification, we need to add different types of external band. So basically this type of external band make your dataset very strong. Basically when I add this type of index or this type of NDVI, NDWI or SABI, then all of bands also extract the information for NDVI pixel value, NDWI pixel value, SABI pixel value, and create the more strong dataset. So this more strong dataset easily distinguish between different types of classes. Okay, so further we'll discuss about that how we can easily add this type of external band and also use it. And this thing is very helpful to increasing your accuracy. Land use land crop classification accuracy, you can also increase it. So let's go. So just I simply select the bands. Now we talk about that make the training dataset. Okay, basically training dataset is stored all of training points pixel value. Okay, training point, suppose all of training points, suppose this training point extract all of band pixel value. Okay, this training point total 164. So 164 training sample extracts all of bands pixel value SRB 1 to 7, all of bands. So let's go try to extract the band pixel value. So let's just take a variable. Suppose I put the variable name is suppose training. You can put any name. And now I just call the image. Okay, so just I call this image. So this image is stored this imagery, who is acquisition 7th January. So just call this image, and in this image I just simply select all of bands. Okay, so for that just use here the dot select function and call these bands. Just copy and paste here, just call. So this is the image. Basically it's come from here. From this image I choose only for those band, which band I want to use to extract the band pixel value, and after that just use a function, it's called the sample regions. Okay, this function we already used for the previous class, so same function you also apply, sample regions. Basically this function help you when you extract the information from a collection. Okay, suppose in this case I have total 164 point collection and I want to extract the band pixel value, so that's why you need to apply the sample regions function. So if you simply search here this function sample regions, you can see this is the function. So this function you must need a collection. So if I just import this function, it will be imported. So here you can see sample regions, this is the function collection. Okay, we already make the collection samples, total 164 points collection, then paste here. Then properties, we already defined the properties all of classes. Okay, all of classes we already set the property name, we can see the class. Okay, same property name we also put in here, so just write here class. Okay, whose name you could just input in here, this same name you also need to mention in the property. And you can see it show the properties, basically it's a plural form, so that's why you must indicating as a list. Okay, basically all of are the same property name, and when you find out this type of argument properties plural form, you must use here the square bracket because it's a plural form, square bracket just put in here. Okay, then scale is the resolution of your satellite imagery. In this case we are just land set for 30 meter we keep, and others not need, just I remove, it's not need. So now if I just print, suppose just print the training and run it, so now all of training sample extract this type of all of bands pixel value. From the properties, from the feature you can see, just click on here, we find out that 8 properties you can see. For the class 0, class 0 means that we already know class 0 mainly water. So for the water, for this point basically for it's extract all of pixel value SRP 1 to 7. So if you check, this is the class 1. Okay, it extract all of band pixel value for this point. For this point it extract the all of band pixel value. Okay, for this point it extract the all of band pixel value. Okay, so this is my data set. Okay, so this is the data set. So further we are use the data set and train our model. Okay, further this model simply connect with our satellite imagery, then it automatically classified water body, build up, vegetation and barren land. Okay, so anyone in question regarding this topic, you can ask me please, or any confusion for any line of code you can ask me.
Hello.
Yeah, please.
Yeah, if we have different kinds of crops, then what we have to do then?
Okay, so for that basically crop types classification, you need the ground truth data. Suppose for the different types of crop, you simply use the ground truth data for different types of crop. So if I show you the one example for the crop types, how we can easily work with that, then it will be more better. Just a minute. For the crop types classification, how we can, same process, but we also need to import the data set for cropland for different types of crop, but a process is the same. So let's go. Let me show you my previous code. So let me open it. Okay, so if you check it, this code, so in this case we are just take this ground truth data. If I just run it and show the result, Okay, so this is a study area. Suppose in this case we try to make the crop classification for year 2017 data I have. So it also make this map for 2017. So rice, cotton, fodder, maize, sugarcane and wheat, we try to classify it. So now this type of rice, cotton, fodder, maize, sugarcane and wheat, so this information it's come from this CSV file. Okay, so this one kind of CSV file. So this CSV file we simply add the latitude longitude for each crops. Suppose for rice, cotton, fodder, maize and sugarcane. Okay, so if you check the feature, so you can see it show the 0. Okay, 0 is for rice, then 1 is for cotton, then 3 is for fodder, 4 is for maize, sugarcane 5 and wheat for 6. Okay, so we create the total 6 class and you can see basically it this CSV file including latitude, longitude and also class mainly level. You can see 0 mainly all of 0 it's indicating about the rice, then all of 1 it's indicating about that cotton, all of 2 is indicating about the fodder, all of 3 maize, all of 4 sugarcane, all of 5 wheat. Okay, as well as we also try to add here, if you check we also add here you can say other class. Suppose you can see the barren land. So if I check what is the class number, you can see 6. Okay, because I already have total 0 1 2 3 4 5 and then I put the 6 because in this case for the barren land training sample I collect from my satellite imagery. So if you check it for the barren land, so I take it from my satellite imagery. Also you can see urban I collect from my satellite imagery, water I collect from my satellite imagery, forest collect from the satellite imagery, grassland I collect from the satellite imagery. But this type of information I include from ground truth or training sample. And how why I classified other class? If I don't classified this type of classes, then this type of pixel is also mixed with rice, cotton, fodder and maize, and then it destroy my crop types classification map. So that's why it's very important when you work with crop types classification. First of all, you just make a this type of CSV file. Okay, suppose this CSV file have a one column latitude, longitude and class. Suppose all of 0 indicating about the rice, so put the class name rice 0. Okay, 0 mainly level, then cotton for 1, then fodder for 2, then 3, just serially. After that you all suppose you also need to classify other pixel. Suppose for the barren land, in this case you can see the barren land we put the same property name. You can see the property name is the same class and 6. Okay, then put at that second urban, you can see it show the 7. Okay, then you can see the 8. Okay, then 9 10. Okay, so total 10 class. Okay, we try to classify total 10 class, and this if I don't classified this type of classes, then this type of classes pixel value also mix with rice, cotton, fodder, maize, sugarcane, and we don't get the more better map. Okay, so that's why we also classified this type of pixel separately. So that's why finally we can easily generate this map. If you check it, suppose the final map, suppose you can see this is that this one is for okay, so this is the total 10 class and this is only for the crop. Okay, it's only for the crop classification. Okay, first one crop classified. Okay, mainly it's this layer including only for the 6 crop classes, because others suppose this type of things I simply remove barren, urban or water, forest, grass, simply remove. Okay, so this is the same process. Okay, but in this case when you add the crop types classification you need this type of data. So I also send you this code, you also try to study and then you can also collect the data and also add up for your own study area.
Okay, sir, I understood this much.
Yeah.
I wanted to ask, suppose you have forest, grass, and you have crops as well.
Yeah.
So, for forest and grass, you have just taken it from the satellites,
Yes.
and for this vegetables, you have taken the coordinates. Am I right?
Yes.
Yes. So, how suppose I want to research paper. So how much coordinates I need to take for ground truth data?
As much as possible you can collect. Okay, so basically more than
Okay.
50 or 60 is better, but as much as possible you collect, because when we add the more training sample, then we find out the more better accuracy on our map. Yeah.
Okay. Means coordinates, one place is, suppose one area is there is some cotton crop is there. So in that particular area, I have to take 60 points.
Yes,
Am I right?
yes.
Okay. Not 60 areas are needed.
Yeah, yeah.
Okay. Fine. Thank you, sir.
Okay, okay. Okay, so let's go try to discuss in here. Yeah, so now we extract this type of spectral signature value and create this type of data set. So now after that we need to just what is the next step? If you check, we need to split the data set, okay, into training and testing. So this split ratio, uh, basically you can check some paper, they are used at the 80% data to train, 20% data for test. Some paper use 70% data for train, 30% data for test, or some paper also use suppose 60% for train or 40% for test. So it's different on you. So in this case, suppose I just spill the data 80% and 20%. So 80% data we train, and rest of the 20% data we try to use it for check the validation, mainly testing. We test our model performance using the testing data. So let's go, we try to explain about that one by one, how we can easily apply training